up an atom. What is chemistry? Chemistry is a whole lot of things. It's medicine, so, the medicine we take for when we're sick. There's science, it is a science. Food, it's in the food that we eat. It's what gives it the flavor and the smell. The air we breathe in chemistry. Life, it's everything that's living around us. And matter, everything that exists. Chemistry is everywhere.
What do all these things have in common? We've got a chair, we've got a spoon, we've got a PlayStation controller. What do all these things have in common?
Oh, they're all expensive.
They're all things that you can have fun with, because chairs, you can spin on the chairs, you spin around in a circle, and spoons, ice cream, yes, ice cream's fun, and video games, pew, 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 pew.
Well, they're all in a house. They're all the stuff.
Yeah, so all these things, they're all made up of matter. But what exactly is matter? Well, matter is anything that has both mass and takes up space. So all those objects, they all took up space, and they all had mass. So this also means that we're made of mass. Everyone's made of mass.
So what is matter made of? Matter is made of teeny tiny particles called atoms. These atoms are so small that we can't even see them. Atoms are made of even tinier particles called protons, neutrons, and electrons. Now, how do atoms stick together? Atoms are grouped together to form molecules. They are held together by chemical forces like covalent bonds and ionic bonds. So we mentioned a covalent bond and an ionic bond. Now we have to figure out the difference between the two. So first we have a covalent bond. This is sort of like atoms sticking together because they're sharing what's called an electron. So we talked about the atoms being made up of little tiny electrons. So these guys basically share their electron with each other, and because they're sharing, they stick together. It's sort of like sharing a snack with your friend, okay? So when we have this little picture show up, we have fluorine and hydrogen. Fluorine has 7 oranges, and hydrogen has 1 strawberry. Fluorine really likes strawberries, and hydrogen really likes oranges. So they're gonna sit at the same table at lunch so they can share. And that's kind of what's happening. They stick together. So next is an ionic bond, and you can sort of think of this as a pair of magnets, okay? So you see these magnets down here? They stick together because of the positive and negative forces. So they're opposites. Have you ever heard the saying, opposites attract? So they kind of stick together like that. And when a bunch of these ions come together, you get this sort of thing.
So in this video here, we have a sodium ion fuses with a chloride ion. So they come together, forming an ionic bond, making sodium chloride. And you've probably encountered sodium chloride before. It's like table salt, so you can put that on your fries or whatever. So this is the video here.
I'm at the Pizza Hut. I'm at the Taco Bell. I'm at the combination Pizza Hut and Taco Bell. I'm at the Pizza Hut. I'm at the Taco Bell. I'm at the combination Pizza Hut and Taco Bell. Wait, we're at the Pizza Hut. We're at the Taco Bell. We're at the combination.
Okay, so how many molecules are in a single grain of sand?
A lot, like over 10.
4.
348.7, exactly.
1. Okay, there's 1.1 times 10 to the 20. So that's 110 quintillion molecules in 1 grain of sand. The elements. There's only a certain number of types of elements. So atoms have to be one of the elements. Okay, what is an element? Here is all the elements on the periodic table of elements. So each one of these colors represents a different group. So some of the main groups are here. The orange ones are the alkali metals. These yellow ones are the alkaline earth metals. These green ones over here are called the halogens, And these blue ones on the end are the noble gases.
Okay, so I'm sure you guys have heard of the Among Us game. Here's a list of some groups of elements, and we're going to give you a hint here. The imposter is a noble gas. So I want you to look at your periodic table that we gave you, and I want you to find the noble gas.
It's Al.
No, Oswald, it's neon.
So neon was the imposter.
And now for our next clue. The imposter is an alkaline metal.
Ooh, it's V.
Nah, it's sodium.
Sodium was the imposter.
Okay, this is the next one. So the imposter is a halogen.
Oh, it's a yellow guy. It's V.
Bro, it's bromine.
So your next hint is that the imposter is an alkaline earth metal.
Ooh, it's calcium.
Yeah, you got it right.
The imposter was calcium.
No way. So, what are the different types of matter, you might ask? Matter can be found in 3 different states: solid, liquid, and gas. Now, what makes each state different? Solids are made of tightly packed particles. Liquids are made of loosely packed particles, and gases are made of widely spaced particles, as you can see here.
Okay, so what is the state shown right here?
It's a
Gas.
Okay, so this is a gas. Okay, so what state is this?
solid. It's a solid.
This is a solid. Okay, what's the state of this picture here?
It's
liquid.
So next we're going to talk about diffusion. Diffusion is something that happens in liquids and gases. We're going to talk a little bit more about gases here. When you spray a bottle of Febreze, what happens? Can you smell it from across the room? Does it take time for the smell to travel? Is the smell as strong across the room as it is right next to you? These are a lot of questions that diffusion can answer. So when a gas is sprayed in the air, really close to the bottle, it's more concentrated, so there's more little bubbles of gas, more particles of gas. And as you get further from the bottle, they spread out more. This is called diffusion. So we're spreading out. So this is how a smell travels across a room. So it can be something pleasant, something unpleasant. You can have all sorts of things. So I'll get my assistant to pass me the Febreze. So with just a little spray, you can kind of see the cloud coming out from here. And as you go further away, it gets like less and less opaque. So that's the gas particle. So really, right here, I can smell it really strong. But if I were to stand across the room, I wouldn't smell it right away. It might take a few minutes, and then I'd smell it over there, and it would be less strong. Febreze, buy it at your local Walmart.
On the topic of gases have to follow certain rules too. See little gases running away from the police? These gases have certain laws that they follow. This one right here is Boyles Law. Boyles Law basically states that when you squeeze on something and it takes up less volume, that the pressure inside of it will be greater. And sometimes if the pressure is great enough, it can burst. Take an example of squeezing on a balloon. Squeezing on a balloon will make it smaller and less space the gas takes up, the more pressure it has. And we also have Avogadro's Law. Avogadro's Law basically states that when you add more of a gas to something, the volume of it will increase. Imagine you have a flat bicycle tire and you need to fill it up. You put more air into it and the tire will get bigger. Another example of this is when you have a balloon. You pull the balloon up, and this might take a while. Wow, this obviously has a lot of pressure in it right now. As we fill more and more moles of gas into it, it gets really bigger, really bigger. And obviously, sometimes they get really big. Like that. Next, we also have Boyles Law. I mentioned a hot air balloon. Well, the reason why a hot air balloon rises is because the warmer the gas, the more space it takes up. And the more space it takes up, the more buoyant it is. But why does warmer gas take up more space than, let's say, a colder gas? Well, that's because warmer gas molecules, when they get warmer, they get heated and they move around a lot more. And when they move faster and more often, then they kind of bump into each other harder and harder, kind of like bumper cars.
Let's talk energy. So energy is different depending on the temperature. So when you think of something hot, you may think of fire. But if you think of something cold, you may think of ice. So this all has to do with kinetic energy in atoms. So heat has a lot of kinetic energy, but cold, not so much. So what is kinetic energy? So it's the energy that has to do with the motions of atoms or molecules. Okay, so this is how a temperature affects food coloring. So we get 3 different jars, filling them with different temperatures. And we add food coloring and see what happens. So we put food coloring in the cold water and the food coloring barely moved. But in the hot water, the food coloring spread all throughout the jar.
This is the cold water, and this is the hot water.
So why did this happen? So because the atoms in the heat move faster than the atoms in the cold. So the atoms in the food coloring move the fastest in the hotter water, so it moved throughout the jar.
As you can see, chemistry is really cool. It can be used to explain all kinds of things that make up parts of our everyday life.
Rad.
The end!
So energy is different, pretend.
I want to be some confused elementary student. Hi, I don't know what I'm doing here. Are you making a funny face in the background?
Include that. Include that here. It's working pretty good.
Wait,
though.
it is working though. That's the right
We
one.
can edit out the volume for this part.
No, I'm leaving it in. Okay, guys, we're going. Oh wow, dance move.
It would make more sense to do upstairs.
Ooh, am I recording?
Yes.
That's scary. So
Pretty
cute.
cute.
I hope it's taking a video. It's so cute. So cute.
They're all the gas takes up, the more pressure it has. The gases in the diffusion part, they have to follow the same rules that we do. No. That doesn't make sense.
Breathe. So with just a little spray. My cat's I don't want to spray the cat. You can see it. You could kind of see it. I hope. Could you see that, camera?
I don't know.
I think yes.
Okay.
I wasn't paying attention.
This is a mess. I'm gonna ask her after I. Okay. She's still recording?
Yeah.
Is it still recording?
Yeah.
Okay, let's go. Keep it running. How do I word?
What are you trying to say?
spray a gas? I'm trying to
Oh,
explain
you're
it.
explaining it for Reese.
The diffusion is basically where you spray a gas. You spray a gas. That sounds like a skunk.
Can you spray
It's fine.
gas?
The first part of that.
1 second, I'm gonna. What types of matter, you might ask?
Karen, when you're editing this, put the video in of the NaCl. Thank you. Goodbye. Love you.
So in this video here, we have
Matter is anything that has both mass and takes up space. So all those objects, they all had mass because they all took up space and they all had mass. So this also means that
Chemistry is everything, everywhere. I messed up.
Keep that.
Well,
Keep it.
I'm gonna keep recording. We'll edit this out. No more of this. Okay, Karen, you can do it again. It's okay.
Is it gone?
Your phone.
Sounds
It is
good.
recording.
Now hit it again.
As you can see, chemistry is really cool. It can be used to explain all